Alright, so we're going to take a look at differentiating trig functions. So you're going to make a new tab, make 2 lines, write the word trig. The biggest thing you need to remember, and you have to memorize this order, I remember it this way, it goes sine, cosine, minus cosine, every other thing. So it goes positives, then it becomes negative. Sine, cosine, negative sine, negative cosine, and then it goes all the way back to the top and starts sine x. So sine, cosine, negative cosine, then back to sine x. That's how you differentiate trig functions. So it's easy to remember. The other one I remember is pst, pst, with a silent p. So we're going to cross out the p. Pst. And what that stands for is secant, secant, and tangent. And then I remember take the cotangent, the cosecant, and the cosecant. So what is cotangent? What does that stand for? That stands for cot. And then cosecant is CSC, cosecant CSC, and then you remember to change that to a negative. So you have to memorize it. This is just how I remember it. You do whatever you need to do. So the derivative of secant is secant x tan x. The derivative of tan is secant x times secant x. Derivative of cosecant is negative cosecant times cotangent. Derivative of cotangent is negative cosecant times cosecant. You just follow the direction of the arrows. Alright, so we're going to take a look at some examples just to make sure that we can use these to find the derivatives. Again, if you have a different way of remembering it, whatever works. This is just how I do it. This is a listening check. Color in derivatives. Color in derivatives. Alright, so let's say that we have this question. We're going to take the derivative. Now, to take the derivative, you can write that as y prime, or you can write it as the derivative of y over the derivative with respect to t. So the derivative of t. So what you're taking the derivative with respect to. So 5 sine t. So again, I need to remember it goes sine, cosine, negative cosine. So the derivative of 5 sine t is going to go from sine, follow the arrow. So it goes from sine to cosine. So that's going to be 5 cosine t. Plus the derivative of 3 cosine t is going to go from cosine to negative sine. So negative 3 sine t. And then let's simplify this. 5 cosine t minus 3 sine t. And that's pretty much all there is to it. So it gets a little bit complicated, but it's the same steps. Let's take a look at another example. This is a listening check. Underline example 2. Underline example 2. Alright, this one is actually taking the chain rule, because you have the mommy, which is the outside, which has a power. Take the derivative of the outside and then multiply by the derivatives of the inside. So the outside, that's the power. So again, let's get used to derivative notation. It's t prime, or the derivative of t with respect to what? What's in there? S. So the mommy is the powers. So take the derivative of the outside. So that's 5 times 4 is 20. Tan, 5 minus 1 is 4. Then everything stays the same. Times the derivative of the inside, which is the baby. There are 2 derivatives. Tan and 2s. There are 2 derivatives. We're having twins. That's what it is. So derivative of tan. So remember, psst, with the silent p, cross off the p. So that's secant, secant, tan. And you better go ahead and write everything down over and over and over again, because I'm trying to get you to memorize it. Alright, so we can see the derivative of tan is going backwards. So derivative of tan is secant x times secant x. So the derivative of tan of 2s is secant 2s, secant 2s. Secant 2s times secant 2s. Times the other twin baby, because we're still in the inside, which is 2s. Derivative of 2s is 2. Alright, let's simplify this a little bit. So we're going to get 20 times 2, which is 40. So 40 tan to the 4th power of 2s, and then secant squared of 2s. And that's pretty much it. So guys, this is not complicated. The biggest thing is you need to memorize the shortcut. So this is another chain rule problem. You need to recognize when to use a chain rule. So again, the derivative of s, or the derivative of z with respect to what? Respect to u. So dz du. Alright, so again, this is a chain rule. You take care of the mommy, take the derivative of the outside, the mom, and then multiply by the derivative of the inside. So derivative of outside is a power. 3 times 4 is 12. Cot, 2, because you're going to subtract 1. Times the derivative of the inside. So you got cot and 4u. So derivative of cot. So you write silent p, which stands for tan, secant, secant, and then cot, cosecant, cosecant. The one in the middle is always negative. Alright, so cot is going to go this way, so it's going to be negative cosecant times cosecant. So negative cosecant of whatever it is for u times cosecant for u times the other baby. So this one has twins because it has someone, times 4. Derivative of 4u is 4. So z squared or dz du is equal to 4 times 12, which is negative 48 because of that negative as well, negative 48. And then we have cot squared 4u, and then cosecant squared, because it's cosecant times cosecant, of 4u. And that's pretty much it, guys. And again, I just want to reiterate, the biggest thing is practice. You just have to practice. Right. We can rewrite this so that I can do it, which is secant to the negative 2x, moving it to the top. Alright, now let's take dy dx, taking dy with respect to x, and we're going to get negative 2 secant and subtract 1, negative 3, times the inside, the derivative of secant x. So silent, secant, secant, tan. So you're going to start from secant and you're going to the right, because you're taking the derivative of that. So you're going to get secant x tan x. So secant x tan x times the derivative of the inside, which is 2. The derivative of x is just 1. Alright, so let's simplify this a bit. We're going to get negative 2 secant cube, because you're just moving it down, so it becomes positive. And then on the top we have secant x tan x. Oh look, I can simplify the secant x's, right? So I'm going to get negative 2 tan x and then get rid of 1, leaving secant squared x. And that's pretty much it. This is a listening check. Color in example 5. Alright, just because it has a square does not mean it's difficult. So the derivative of cosine. So derivative of cosine, follow the arrows, it goes negative sine. So negative sine of whatever that is times the derivative of the inside, which is the derivative of the square root of 3x. So what does that mean? That's the same as 3x all raised to the power of 1/2. So put parentheses around it. There you go. So then take the derivative of that. So it's going to bring the 1/2 down. So 1/2 3 to the x, and then subtract 1, which is negative 1/2. So 1/2 3 to the x in parentheses, all raised to the negative 1/2. So I'm just going to write it here clearly. Obviously, don't write it there. All times the derivative of the inside, which is 3. We're going to go ahead and simplify this. You're going to get f prime of x, the derivative is negative sine of that, and then 1 over 2 is so 2 on the bottom, and then square root of 3x, and then times 3, which goes on the top. So it looks like that. Let's take a look at one more example. This is a listening check. Put a box around f of x. Put a box around f of x. Alright, so again we're taking the derivative of f of x. So derivative of tan is so it's secant, secant, tan. Tan is going from right to left. So tan is really going to be secant squared. So derivative of tan is secant squared of whatever the function is, times the derivative of the inside. So derivative of this, we need to do a quotient rule. So low d high minus high d low all over low squared. So let's go ahead and do that. Low d high, so the low is x plus 1, times the derivative of the high, which is 1, minus high, which is x, times the derivative of the low, which is 1, all over low squared, x plus 1 squared. Alright, so let's tidy that up a little bit. Alright, so what can we do? Okay, so that's x plus 1 times 1 is x plus 1, and then negative of x all over that, which is equal to x minus x is 0, so 1 over x plus 1 squared times secant squared x over x plus 1. And that's pretty much it. So differentiating trig functions is not hard at all if you just memorize the shortcuts. Let's practice.